Okay, so let's look at some of these graphing problems and how, particularly the ones that we can write as simpler functions. And let's just review how to do that. Before getting there, though, let's do b of x up in the top right. So if I were to look at b of x, a few things I want to make note of is the period here is 2 pi over a third, or 6 pi. And then I'm curious, if that's the period, what's the interval width between the crucial angles I want to plot? And that's going to be 6 pi over 4, or 3 pi over 2. All right, so keeping that in mind, I'm going to create my axes here. And notice there's no horizontal shift, so I'm not worrying about that. But there is a change in the sense from the previous problem that I have a vertical shift. So my midline or my equilibrium is actually going to change here. The vertical shift is up 2. So I'm actually going to, at that up 2, just create a dotted line. It just helps orient me that if I've done my graph correctly, I should be equidistant above and below this graph in terms of the amplitude. So keep on not making this big enough. All right, so let me plot my angles on the x-axis first. So I said the interval width was 3 pi over 2. So after 0, I'd have 3 pi over 2. Then 6 pi over 2, which happens to be 3 pi. Then 9 pi over 2. And then 12 pi over 2, which happens to be 6 pi. And sine normally starts at the midline, so starts at 0, goes up to 1, 0, -1, 0, if I'm going around the circle. So I'm starting on the midline, but it's just the midline now isn't at 0, 0. I'm going to be up at 0, 2. And then I'm going to go up to my highest point, and because the amplitude is 4, this highest point will now be up at 6, so 4 away from the midline. Back to my midline, then 4 below the midline, which will be -2 in this case, and then back up to the midline. So that's one full period there, which I then could extend into the negative direction if I wanted to draw more than one period or show that it continued in this same way. It would just continue on like this. So that would be the graph of 4 sine 1/3 x plus 2. So let's look at, again, some of the more complicated looking graphs just to show you how I can make it easier. So if I look at, actually, let's look at something like e of x here. So it's this piece that I'm convinced I can make simpler. So sine of x minus pi, well, or I could say sine of -pi plus x. So if I think about where this angle is, if I do -pi, which is over here, and then add some angle x, and for our purposes, I'll just say that, x is acute, just for simplifying purposes. So we're really evaluating this angle here, and in quadrant 3, sine is negative, so this is just the same as negative sine x. So rewriting what I have here, I have sine x minus negative sine x, or in other words, this is just 2 sine x. So I'm confident you guys would be able to graph that. And so again, looking to simplify these pieces. Let's look at a problem on the next page here. Okay, so k of x, in fact, I don't have one of those angles that terminate on an axis, so I am going to have to deal with a horizontal shift. So let's see if I can deal with that. So the first thing that I'm going to do, just as before, is the period is 2 pi over 2, or pi. You always look to what's in front of the x. And the other, so the interval width is pi over 4. But this plus 2 pi over 3 means instead of starting at 0, when there's no vertical shift, if I want to do one period, I'm actually going to start, it's a shift left 2 pi over 3, so I'm going to start at negative 2 pi over 3, but then dividing that by 2. So in other words, so let me back up a second. So I know I want to evaluate cosine of 0 because that's what we start at 0, then pi over 2, pi, 3 pi over 2, 2 pi. So let me just figure out what would I have to put in for x so that I'm doing cosine of 0. So 2x equals negative 2 pi over 3. So I'd have to put in negative pi over 3 here. So that's going to be my starting point. And I'm not going to do this for every value. I'm not going to do it for pi over 2 and pi. I'm going to use my interval width for the rest of them. So let's start at, whoops. And notice there's no vertical shift. So my midline is the x-axis. All right, so just make myself some room here. And so I just said negative pi over 3. Which is the same as negative 60. And then the interval width is pi over 4. And actually, I'm going to make myself some more room or else this isn't going to be pretty. So let's just do it over here. Negative pi over 3. So the interval width, again, is pi over 4. So to figure out the next angle that I'm going to plot, I'm going to do negative pi over 3 plus pi over 4. And that is going to be negative pi over 12. So negative pi over 12. And then if I add pi over 4 to that, so 3 pi over 12, I'm going to get to pi over 6. And just be careful with the interval width in the sense that these should be the same distance apart. So these are the angles I'm plotting, and then so pi over 6, or I should say that was when I added pi over 4, that was 2 pi over 12, which is pi over 6, and then adding another pi over 4, it would be, so I'd get 2 pi over 12 plus 3 pi over 12, and I'd get 5 pi over 12. And then so then let's see what I've got so far. Actually, let's do one more. Add another pi over 4, which is 8 pi over 12, or so 8 pi over 12, which is 2 pi over 3. All right, so let's see when I then plug. So normally cosine is 1, 0, negative 1, 0, 1. But because the amplitude is negative, it's going to be negative 1, 0, 1, 0, negative 1. And remember, my new 0 is negative pi over 3. So I'm going to do it in blue. So, and we're going to say negative 1 and 1. So negative 1, 0, 1, 0, negative 1. So there is one period here. And let's just double check. If I put in 2 pi over 3, that should be the same for x. That should be me doing cosine of 2 pi, which indeed is the case here.